All right, so 1-4 is called perimeter and area. So the topic is perimeter and area in the coordinate plane and classifying polygons. A lot of review, perimeter and area, hopefully stuff that we've been doing a long time. We're gonna then put it in a coordinate plane, and then we're gonna learn how to classify polygons. Okay, so there's some vocab there. So the word polygon, poly means many. So this is many angles, okay? A polygon is a closed, which is important. It has to be closed. There can be no open spaces. A closed plane figure formed by coplanar segments. So the sides are segments. And in order for it to be a polygon, so you're going to get a picture and it's going to say, is this a polygon? And it's a yes or no. It's a yes if each side intersects exactly two sides, no more, no less. If no two sides with a common endpoint are collinear, meaning they can't lie next to each other, that would be the same side. And each endpoint of a side is a vertex of the polygon. So there's no like open-ended endpoint somewhere out there. So simple, yes, no. Identify the figures that are not, oh sorry, this is not the yes, no. This is find the ones that are not polygons. So from here, what's not a polygon? Sebastian. B? Why?
Because it's open.
Open, good. Not polygon. What else is not a polygon? Go ahead, Santi.
E.
E is not a polygon. Why?
Because it's not closed.
Yeah, you could say it's not closed. You could also say that each segment doesn't intersect two segments, right? Like this bottom one intersects two segments, but it's one at each endpoint. So there's a lot going on here, right? Each side must intersect exactly, so no more, no less, two other sides.
Wait, what do you mean intersect?
One at each endpoint. Oh, I spelled endpoint right. So like this, like look at this segment, right? This segment that's here intersects two other sides, but not one at each endpoint. Does that make sense? There, it's intersecting two, but at the same endpoint. This side here is doing the same thing. It's intersecting, meaning it connects with, so it's intersecting because they both touch at that point. Intersecting two other segments, but not at each endpoint. They are both at the same endpoint. Sophia.
Isn't C also?
C is also not a polygon, and why is that?
Because it intersects on more than 2 points.
Good. Same thing. It's going to intersect, each of these are intersecting more than one side. If I just picked one side, like let's say this is a side, that side intersects this side, it intersects this side, it intersects this side, and it intersects that side. So anything that's going to cross through the middle, not a polygon. Anything that doesn't have a side or something's missing, not a polygon. Anything that doesn't have space inside, like E, if it was not like, you know, like there's no space inside that, not a polygon. Questions? All right, convex polygon. So now we're classifying the polygon as either convex or not convex. Okay, a convex polygon has no line that contains a side of the polygon containing a point in the interior of the polygon. It sounds like the weirdest definition, okay? And basically the test is if you extended the sides of the polygon and that extension went into the interior of your polygon, it is not convex, okay?
So if it's like a star, it's concave.
Correct. So if you look at this, which your book actually says convex or not convex. It doesn't say, oh no, it does say concave. Sorry, yes, some books say concave and some books don't. Yours does. So if I look at the one on the left, obviously it's a polygon, so that it met the first qualification. If I were to take and extend each of these sides out in both directions, none of these extensions cross into the interior of my polygon, which is what makes this convex. So that's your test, okay? If I extend, God bless you. If I extend any side, does it go to the interior of your polygon? If it does, it's called concave, which is the next size. If it doesn't, like these, it's convex. So if we did the same on that second one and we extended it in all the directions, none of those cross through the interior of the polygon. So these are all convex. Okay, so a concave polygon is the opposite. It has a line that contains a side of the polygon that would contain a point in the interior of the polygon. So even if not all of them do it, like if there's just one side, which there would always be two that somehow cave in, if there's at least one side that when you extend it, it crosses into the interior of that polygon, then it is concave. If you think about it like caving in, that's what it would look like, right? It would actually like collapse into it. That would be concave. All right, names of polygons. 3 sides is a triangle, 4 sides is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon, 11 would be an 11gon. Yes. So if it is not on this list, you literally call it the number of sides dash gon. It could be a 25 gon. Yep, I don't know why 11 got skipped over. It seems kind of rude, but it did. Okay, right? So I would say the biggest, like most, I would say this is not a difficult thing. Most people remember this thing. I think the thing that we screw up the most is the 6 and 7. Hexagon has an X in it, so does 6. Okay, so those two go together, and then heptagon is the 7. And then there's not a whole lot of like dodecagons discussed before high school, or at least before you get into geometry. So that one might also be new. But the rest of these you have to know. And you would have to know it because the directions might say a nonagon has blank, or find this about a nonagon, and you have to know that that's 9 sides. All right, this says tell whether the figure is a polygon and whether it is convex or concave. You do these. All right, so is a polygon?
No.
Why not?
There's a line.
It needs to be open on the inside, yes, right? And then it can't, this is not connecting at the end points, right? One at each end point is the problem. That one in the middle. If they were separated out, it would be fine. How about B? Yes. And it's good, convex. What would be the name of it? Hexagon. 6 sides. Yep. How about C? No, because curved edge. And D? Yes to the polygon. Concave. What would it be named? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. Dodecagon. Dodecagon. Oops. All right, classify the polygon by the number of sides and tell whether the polygon is convex or concave. So it's already telling you they are polygons, okay? A is hexagon and convex. B. Oh, it is a parallelogram, but what's the name of a 4-sided? Quadrilateral.
Wait, when you call it a square? No, square.
Does that look like a square? Don't worry, we're going to get into that chapter. Quadrilateral and convex or concave? Convex. It is not a square, actually. A square has to have 4 right angles and 4 congruent sides. It is a parallelogram, I will give you that, but it's not a square. All right, C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon. And concave. Good. All right, now perimeter and area. Okay, we hopefully know these formulas. These are the perimeter and the area of a triangle, a square, and a rectangle. So on a triangle, and there's different ways to find the area of a triangle, but this is the first way. The area would be 1/2 base times height. The perimeter, you add up all the sides.
I was never taught it. Does that?
Okay, well, good. We're learning it today. Yes.
Does that area formula apply to every triangle?
Every triangle, yep. In order to use it though, you have to have the base, which is one of the sides, and the height, which is the right angle. So, I mean, it has to meet at a right angle. So it has to be the perpendicular segment that hits that side. The square is next. So the area is either side squared or length times width, which they would both be the same if it's a square. And the perimeter is 4s or s plus s plus s plus s because that gives you the same thing. Just add up all the sides. So no matter what the polygon is, perimeter, you add up all the sides. These are just special ones that you can use shortcuts for.
How can the rectangles just not add in the sides?
It would be the same thing. So if I did length plus width, it also would give me the perimeter of the rectangle. It's just shorter, okay? And sometimes we need that formula because it'll give us certain kinds of information. We would use that formula. So twice the length plus twice the width, which would also work on the square. It just, they would be the same. And then the area is length times width. Length is the longer side if it's talking about length and width, okay? Questions on those formulas?
Isn't the square also length times width?
Yeah, but they would be the same. The length and the width would be the same. So in the top it says you can use the formulas given below and the distance formula to find the perimeters and areas of the polygons in a coordinate plane. So we're going to plot some points in a coordinate plane. You're going to find the lengths of each of those sides by either using the distance formula or if they're horizontal or vertical, you can simply count. And then you're going to use those to find these measurements. Nico, sure. All right, example 3. Find the perimeter of triangle ABC with vertices A, B, and C. So I'm going to plot A, -2, 3. I'm going to plot B, 3, -3. And I'm going to plot C, -2, -3. So be careful in your homework. If the directions say to plot, you must plot. Some of you lost some points on that last homework because we said to plot it and you didn't. Make sure you read the instructions. All right, what are the easy ones to find the lengths of?
The bottom.
The bottom would be 1, 2, 3, 4, 5. The left side, 1, 2, 3, 4, 5, 6. Now that slanted one is what I cannot count.
15.
You can't count it. So you're going to find the distance using the distance formula. So between A and B, this would be my x1, y1, x2, y2. So AB is the square root of x2, which is 3, minus x1, which is a -2. So what happens to minus a negative?
You add.
Good. So that becomes plus 2. Plus y2, -3, minus y1, 3. I get the square root of 5 squared plus -6 squared. 5 squared is 25. 6 squared is 36. Add these together, and I get the square root of 61. Is that a perfect square?
No.
Can I break it down? Does anything go into 61? No. Okay, it's prime. So if I want to find the area, the perimeter, it is 5 plus 6 plus the square root of 61. And I can combine the 5 and the 6, but I can't combine the square root 61. So if I didn't have a calculator and it wanted it kept exact, I would keep it like that, okay? If you were given the calculator and it asked you to find it to the nearest tenth, you would square root 61 and then add it to 11 and round. But for homework purposes, keep it exact because that's how it would be on a test. Questions on that one? Vertices of D are 1, 3. E, 4, -3. F, -4, -3. Here's my triangle. What's the easy one? To get the bottom, right? 1, 2, 3, 4, 5, 6, 7, 8. It's the only one I can get that way. So that is the base. Now what else? What's the formula for the area of a triangle?
1/2 times the base
Good. So you have the base is 8, right? Where can I find the height?
Distance from the, you can't.
Has to go from the opposite side of the base. So because this is, with the base is our bottom, right? Opposite side of the base, which would be D up here, straight down, and it has to be perpendicular to the base. Okay, it has to form a right angle. So can I count that one?
Yes.
Yep. 1, 2, 3, 4, 5, 6. That's my height. So it has to be perpendicular to the base, has to form that right angle. So 1/2, base is 8, height is 6. And you could do this like 7 different ways. I could cut the 8 in half and then multiply it times the 6. I could cut the 6 in half and then multiply it times the 8. You could do it 3 different times. Or I can multiply 8 times 6 and then cut it in half. So you get to choose. I tend to, if it's even, go with the first one and then multiply it, and it's 24. It doesn't have a unit on it, so you can just put unit squared because that's your generic unit, okay? If it said centimeters, inches, whatever, then that would be that measurement squared. Questions?
So what if there was an instance where you couldn't count the height?
Then you'd have to find the distance. Well, you would have to know the coordinate point. So let's just say you'd have to know this coordinate point and this coordinate point, and then you'd have to use the distance formula. Like let's say it's rotated. Like if it's like a this, right? I'd need to do this distance formula, and then I'd need to do this. So I'd have to do the distance formula of those two sides. Yep. Questions? Good, not so bad, right? Okay. I'm gonna open up your assignment so you can get a head start on it. Maybe let's get